School math is different from real math. In the real world, math is used to model the behavior of cars, heat, electricity, money, your heartbeat, and a million other things. Throughout history, scientists and mathematicians have embraced technological innovations like formulas and aids to calculation like logarithms. In our age, we're lucky enough to have advanced technology that can help us solve math problems instantly that would have taken our predecessors hours or days or longer. However, most math students are taught to solve math problems by hand, like some medieval scribe. Why? It's because schools have to keep students busy for 180 days per year and for 4 long years of high school. Textbook companies are more than happy to sell thick books to schools year after year. Students are kept busy for a year of algebra, which is the art of replacing numbers with letters, a year of geometry, the art of analyzing shapes, another year of algebra, a year of trigonometry, which is an extension of geometry using the ratio of sides in right triangles. It really shouldn't take a year. Possibly another year of pre-calculus, which I guess is whatever comes just before calculus. Finally, the student gets to calculus, a course so advanced and frightening that it's considered the trial by fire of the true math student. Many schools accept that a failure rate of nearly 50% is proof of the difficulty of understanding the concepts and tools of calculus. Then in the 1990s, some schools reached a failure rate of 60% and wondered if perhaps they were doing something wrong. A lively debate took place about the nature of math instruction in higher education that raged for a decade. Finally, a mandate was given to instructors from Harvard University to produce a textbook of reform calculus to improve the situation. Unfortunately, by then, most calculus instructors were so habituated to the traditional way of teaching calculus that the reform calculus text was rejected and schools returned to the traditional way of teaching calculus. This is like a person leaving their abusive spouse, but if their new lover doesn't work out, they have to return to their original spouse. Standardized tests like the AP and GRE reinforce the need to do calculus with pencil and paper. It's not easy to evaluate a student's overall understanding of math, but it is easy to tell if they can take a complicated derivative by hand. I would have less of a problem with this if the fields that use calculus, like business, engineering, science, medicine, and so on, limited people to calculating by hand, but they most certainly don't. People in our society are expected to be able to do things like adding and subtracting without automatically reaching for a calculator, but beyond a certain point, technological assistance is perfectly forgivable. If you use a calculator to solve a division problem like this one, people will understand. Just like accountants use calculators and computers for their arithmetic, engineers and analysts, using advanced math, use software to model phenomena, take derivatives and integrals, and solve equations. So why don't math classes teach these new tools? Math teachers were taught the pencil and paper way to solve problems, and many of them are not familiar with graphing software and computer algebra systems. And as we've seen from the reform calculus debacle, there's a lot of ingrained habits keeping new ways of teaching and learning from being tried. I've been a teacher and tutor for over 10 years, and I've had many students who were not responding to the traditional way of learning calculus. They came to me for help, and for years I asked, why is it being taught this way? Couldn't there be a better way? To answer that, you have to find out what calculus is. It's not a foreign language. It's pretty much a synthesis of algebra and geometry. Algebra is used to find out quantities you don't know, so you assign them a letter, a variable, and work out their value that way. It's very useful. But the quantities have to be the same on both sides of the equation. They can't change. Geometry is used to model physical phenomena using a toolbox of shapes, from straight lines to polygons to circles and other curved shapes. Again, very useful for modeling things that stay the same, but hard to use on things that change. In the 1600s, science was examining the planets, and there was a lot of debate between science and religion about how planets move, because some seem to move backwards. Another big question was whether the Earth moves and how quickly. There was a lot at stake, and science had to come up with something to challenge the Church's authority. What science needed was accurate measurement. However, the planets moved around all the time, and not in nice circles like Copernicus said, but in elliptical paths like Kepler calculated. New mathematical tools were required that could model moving objects in situations that kept changing. Long story short, the tools Newton and Leibniz developed were differential equations. These geniuses created calculus as a means of solving these differential equations. In my opinion, the teaching of calculus should start with differential equations, but it doesn't. For the next couple of hundred years, scientists got busy using differential equations to model everything from heat expansion to fluid flow to strength of materials to this mysterious fluid or field we now call electromagnetism. However, mathematicians were not so busy. They were trying to set calculus on a sound theoretical footing. There were some issues with dividing by zero or something. It's been said that, sure, calculus works great in practice, but does it work in theory? 150 years after Newton and Leibniz invented calculus, and did I mention all the phenomenal work scientists were doing using the tools of calculus in the meantime? A notation was developed that finally gave it a rigorous foundation. This was limits, a concept introduced in the second chapter of practically every calculus textbook. Mathematicians were proud that their field finally possessed the authority of proof and rigor, and that pride is reflected in every calculus course out there, even today. Regardless of your academic major, you're sent to the mathematics department to learn calculus. It's taught as if you're going to be a pure mathematician who loves to analyze theories and prove theorems. Most math professors consider limits vitally important to understanding calculus. I don't, and I'm not alone. Dr. C.K. Raju, the physicist and professor who helped India develop its first supercomputer, also questions the place of limits in a first-year calculus course. And I have an email from a Stanford professor encouraging me to ignore limits as long as possible in teaching calculus, because it's a concept that's not even used by scientists. Which brings me to the calculus course of the future. How much calculus could you learn if you avoided useless abstractions and concentrated on the tools that are actually used in the real world? How much could you learn if you avoided outdated methods and instead mastered modeling with differential equations and using everyday modern methods to understand and solve them? In 2010, I developed the Fun Calculus program as a way to introduce people of all ages and abilities to the tools of calculus and to answer the question from the start, when are we ever going to use this? Can a calculus course really be fun? Well, it's not exactly a chore to meet 6 times as opposed to 180 times. And if you only teach the essentials, you won't be frustrated at having to sit through nonsense you'll never use. And taking derivatives and integrals using pencil and paper is something you'll never do outside of a math class. I think it's fun to use computers to solve problems, and every educated adult in our society is expected to know how to use computers. Will the Fun Calculus program teach you all the calculus you'll ever need to know? No, but it will help you to become your own teacher, having seen the big picture and having learned the context in which the tools originated. At every step you'll learn a straightforward method for setting up equations and solving problems using your brain and 21st century technology.